Good morning, good afternoon, good evening. Thank you for joining me today to learn all about error handling best practices for Lightning Web Components. My name is Aditya. I'm a lead developer evangelist at Salesforce. You can stay in touch with me by connecting with me on either Twitter or LinkedIn using the handles mentioned here. You can also follow Salesforce developers on all of these different channels like Telegram, Twitter, Facebook, YouTube in order to stay up to date on everything that we are doing. I want to call out your attention to YouTube. Since last month, we started launching these tiny little videos that we call as quick takes that show you a lot of things, right from how Shadow DOM works, how you can use CLI for debugging, and many, many more concepts. And all of these videos are very small, like 3 minutes to 10 minutes maximum. So do check them out and let us know what you think. And yes, this session is being recorded and the recording will be available on Trailhead Live within a week. Before we move on to the actual topic, the forward-looking statement, basically make all your purchasing decisions based on generally available information and not based on what I might say today. Now, coming to today's agenda. So we are going to start with a refresher on how you can handle server-side errors. Then we are going to move into handling errors on the client side, that is Lightning Web Components. And as a part of handling all of these errors, I'm also going to cover how you can propagate errors and what are the best practices involved in displaying and logging these errors. So first, let's start with handling server-side errors. Apex, as you know, throws a lot of different exceptions like query exception, let's say DML exception, or one thing that I get quite frequently is, let's say, attempt to dereference a null object. So all of those are different exceptions that Apex throws. And if you don't handle these exceptions, which means you don't put your logic inside a try-catch block, these exceptions become unhandled and they directly get thrown to the client. So a very quick demo on server-side errors. So here I have a tiny little Apex controller, and here it is the same variation. I mean, there are a bunch of different methods, but in the end, all the methods are doing one thing. They are getting a parameter and they're trying to convert the parameter to uppercase. And I've created different variations, as in the first one is it just returns the uppercase string. And this is where it's going to throw an exception if I don't pass the parameter, that is str. So this is when str is going to be null, and if I say null dot to uppercase, it's going to say attempt to dereference null object. Now in the next method, it's a slightly better variant where I'm actually putting a try-catch block around that. And here I am throwing an Aura handled exception. So this, we frequently used it when we were working with Aura. But when it comes to Lightning Web Components, you need not always use Aura handled exception. So like I said, even if you don't give anything, the error will be returned to the client. Now, the other variant here is a custom exception. So instead of using the predefined Aura handled exception, if you want to create your own exception class, then you can do that and then throw that exception. Now you notice here that in the catch statement, I'm not just putting a simple system.debug. I'm actually throwing the exception back to the client, but I'm doing it in a slightly different way. So instead of Salesforce throwing the default exceptions, I'm actually handling it and then throwing my own exceptions that I want. So in this case, instead of the attempt to dereference null object exception, I'm going to send in these two. So let's look at that in action. So here we are. These are the bunch of different Lightning Web components that I have built, each of which is connected to the Apex controller that we have just seen. So in the case of the unhandled exception, I'm just going to invoke that method, and you're going to see there is an error, which is why it has given this error panel. And I also logged the error to the console at the bottom. So if I show the details of the error, you can see it says attempt to dereference null object. And then if you expand the error that you're getting, you can see that the exception type is system.nullPointer, and then there is a standard message that is sent, and all of this. In most of the cases, you should be able to handle this error, but as a best practice, you're not supposed to really let Apex fail this way. You're supposed to catch those exceptions and throw your own exceptions to the client, primarily because of abstraction. So I'm going to show you what abstraction really means. So look at all of these bunch of details that have come into the client. Now the next variant I have here, if you remember, I have handled the exception and I'm throwing the Aura handled exception. So when I invoke that method, you'll see again it still returns an error. But this time, if I expand, you can see I have sent a custom message. So I say something went wrong, and then I say what went wrong. And you'll see no other details are being returned. So in the previous case, we saw a lot of controller names, what is the method name and all of it. So here it's just a plain simple message. Now, very similarly, we are going to invoke the custom exception. So click on invoke, and then there is an error. And if we look at the error now, the exception type is not system exception. It is now my exception, which is the custom exception class that I have defined. And the message is again something that I have passed in a custom way. And what you'll notice in the stack trace of the custom exception is it's going to show you both where the original error occurred. That is in line number 20, there is the original error that occurred, which triggered the exception. And it also shows you the line number from which this custom exception was thrown. So it kind of shows you the entire stack trace that you can use in your Lightning Web Components to handle the error better. Now, finally, there is one little variant here which says no exception. So let's see what happens. So I click that button and pretty much nothing happens. Now, why is that? So if you scroll down, this is the no exception method that I've created, which means I have anticipated that if str is null, there is going to be an exception, which is why I have put a check here saying if str is not equal to null, then do this. If not, return an empty string. So this is not really handling an exception, but it is a way for you to write cleaner code by means that this is not going to throw an exception. You have handled the error by anticipating it. Now, one tiny update that is coming in Winter 21 is you need not write this if statement anymore. We have launched what we call as a safe navigation operator, which means instead of writing this if statement to check for null and all of this, you can just put a question mark right here, which says if string not equal to null, only then execute this dot. If not, return null. So that is exactly what this is saying. So this is a much cleaner way of getting things done. And in case you're wondering, whenever you're passing exception details, like you've seen, it was just a simple string that we were sending saying that, okay, something went wrong. But what if you want to pass a more complex data structure? What if you want to pass what went wrong? What is the severity of that error? What are the corrective steps that need to be taken to that error? You can actually create a wrapper class for that. And it's kind of like a workaround, I would say, because there are very limited parameters that your exception classes can take, one of which is a string. So the workaround really is you define your own wrapper class and of course initialize that, put in all of your details, and then serialize the wrapper class and send it as a string. So this is going to conform to the specifications of the exception class, as well as allows you to send a lot of details that you can then again handle from your Lightning Web Component. So this is a little bit about a refresher, I would say, on handling server-side errors. I mean, you might ask me, why do you need to handle errors on the server side if the exception comes, it is anyway sent to the Lightning Web Component. Why can't I do it just there? Now, the reason you need to handle errors on the server side is because of these three reasons. It allows you to control what errors have to be sent. So for example, in the example you have seen, in the last method, I decided not to send any exception. I thought I'll just handle any errors in the backend itself and either return the uppercase string or return null. So that was a choice that I could take. So that means it allows me to control what has to be sent to the client and what errors have to be handled on the server itself. So let's say there is an exception with a third-party callout that you make. You might want to handle the callout exception within Apex and just return a very simple error string to the front end by saying that, okay, please try again. Now that is where we come into the third point, which says how much detail must be returned to the client. So you've seen all these three exceptions that I showed you in the UI. Each of them return different level of depth. So one of it returned just the error message, the other one returned the class name, the other one returned the stack trace, a lot of things. So if you don't want all of these things to be returned to the front end, you want to do some level of abstraction on what details go. That is when you can choose to handle errors on the server side in all of these different ways. One more, again, this is the final best practice for server-side errors. Decide on a common structure to handle errors and use it in all classes. So, I mean, there are a n number of developers that are going to work on a project, and each of you might have your own way of handling errors. But in the end, it becomes difficult to standardize errors, reporting, and all of that. So decide on a common structure before you begin the project. So let's say you create such a wrapper class, and you agree that all the developers are going to use the same wrapper class in order to report the errors. So that way you also get to control what details are being sent and how much details are going into the front end. So this is kind of a best practice. I mean, I've created these slides to be screenshot worthy. So in case you decide to take a screenshot, please feel free to do that. Now moving on to handling client-side errors. So in the client side, I mean, obviously everything is JavaScript, and Lightning Web Components, as you know, is completely based on web standards. So all of your error handling mechanisms are also going to be based on web standards itself. Now, when it comes to JavaScript, there are two kinds of things that go on. One is your synchronous code, that is your line by line execution. And then there is your asynchronous code. That means your wire services, your promises, set timeout, interval, all of those become asynchronous calls. Now there are different ways in which you're going to handle both of these. So in errors in synchronous code, let's look at a small code snippet. So here I have a connected callback, a lifecycle hook. Then I have a for statement, a bunch of for statements. Console log first, and then I'm throwing some error. Notice that I have used the throw keyword to throw the error. You could do any operation that throws an error, doesn't matter. And then I have two other console logs below that. Now, in the case of synchronous execution, what's going to happen is the console log first is going to get printed. And then we're going to throw an error. So an error is going to occur. And then, of course, after the error, the entire transaction is terminated. So none of the other two console logs are going to get printed. And this sort of fails. So this method execution will fail because there is an error. Now I have tried to rectify that. I mean, the best way in which you can handle errors is using try catch block. I mean, everybody already knows that. So here I have put a try catch block for the first three statements, and then there is this console log third, which I have put outside the try catch block. So let's see what happens. So in the try block, now the first log is going to come, and then there is an error and the second statement is not going to get executed. But then because there is a catch block associated, it's going to execute that catch block and print whatever is the message that is there in the catch block. And finally, it is going to print line number 9, that is third, and my method is successful. So no error is being returned in case I do this. So this is pretty much straightforward. Most of you are already doing it. But now let's see what happens if you try to do the same thing with asynchronous code. So the code is almost the same, but what I'm doing is two of those lines, I have moved it into a set timeout block, which means two of these lines are going to execute after whatever delay I specify, meaning that this is asynchronous. So the first, as usual, the first block is going to get executed, and then the set timeout function is going to get called. So here, what you'll have to note is that set timeout is just a simple function in which you're sending what we call as a callback function, which gets executed after some amount of time. So speaking in Apex terminology, if you consider a transaction, consider set timeout like a future method. So you, in your Apex transaction, you just call the future method, but sometime in the future, the method actually executes. So it's the same concept in JavaScript also. So you are going to display, JavaScript is going to display the console log. It's going to call the set timeout and place this thing in whatever delay in an asynchronous or a different transaction. And then immediately the third console log is going to appear. The reason is, again, like I said, consider this to be like a method callout to a future method, which means line number 2, 3, and 7 are in one transaction. So this is just a function call, it gets called, the third console log gets printed, and your transaction is successful. Now, after a minute, after a second, or after so-and-so delay, the transaction inside this block is going to start. That means this callback method is going to get executed in a different transaction and it's going to throw an error. So because we have specified throw error and then a console log, the error is going to be thrown and the console log is not going to get printed. So key takeaway, again, this is one transaction in which the set timeout method is called. The actual callback function is executed in another transaction. So the first one is successful because everything is smooth, but in the second transaction, there is an error. Now, I have again very similarly put a try-catch block around all of my code so that I should be able to handle this error. But what happens? So in the very same way, the try block get executed first, the first console log gets printed, and then the set timeout function also gets called. Now, like I said, this is just a call out to the function, so that is anyway successful. And then immediately the third console log gets called and this whole transaction is successful. But again, when the callback function is called a second later, it again fails with an error. So my first transaction is again successful in spite of putting a try catch block around it. And my second transaction is failing. Now, why is that? So this is the primary reason. A try catch block only handles exception from synchronous code. That means within your transaction, within a single transaction, if there are any errors, only then the try catch block will help you. If an error occurs outside the transaction, the try catch block is not going to help you. So if you enclose the entire set timeout function in a try catch block, it's not going to work. So what is the fix for that? The fix for that is actually to put your try catch block inside the callback function. So in this case, what happens? Your first transaction goes successful as always. But when it comes to the second transaction, which is your callback function, there is a try catch block for that callback function, which is why if there is an error, it's going to catch it and print the error statement and your entire transaction is going to be successful. So that is the fix. I mean, I'm using the word transaction so that it's much easier to understand, but JavaScript executes in a slightly different way. We won't get into that complexity for now. So this is how you handle errors in synchronous and asynchronous code. This is the basics. But now let's get into something that is very specific to Lightning Web Components. That is a wire service. So first, let's see how a wire service works. You have a client Lightning Web Component, and then you specify your wire decorator and you make a call out to a wire service. So which means first a request is going to go out. And then what happens is the wire service is going to go to a wire adapter to fetch all the data that it needs. And the adapter in turn might decide to go to the Salesforce server to fetch the data, or it might go to the cache to fetch the data. In the end, all that complexity is taken care by the wire service. And then the data is returned back from the wire adapter to the service, which provisions the data to your Lightning Web Component. So you send a request, and then there is this whole wire adapter that does all this work. and then the value is provisioned back to the client. And once you get the value, of course, you're going to work with that value, which means whatever response you've gotten, you're going to do a bunch of stuff on that. So you're going to handle the response. Now, there are 2 points of failure when it comes to wire service. The first point of failure is whenever it is provisioning the value, which means, let's say, when it is going to Salesforce and trying to fetch data from, let's say, your Apex method, and your Apex method throws an exception, then there is an error in value provisioning. If you don't pass the required parameters, or if there is some problem with the cache, I mean, there can be n number of reasons, and your value provisioning might take a hit. So that is one point of failure. Now, let's say your value provisioning is successful and then you're handling the response. That is where you have the second point of failure, where when you're handling the response, there might be some exceptions. Now, how do you handle that? So this is a typical wire syntax. I mean, I have wired it to a function, and this function is doing a bunch of stuff. Now, the error property that is there is going to store all the errors during value provisioning. So in case there is an error for value provisioning, the error property is going to have all those details. And not just when you wire it to a function, but when you wire a method to a property also, the property is going to have a dot error property, which is going to hold all the errors whenever a value is not being provisioned successfully. So the best practice is whenever you have the error, you are supposed to write an else if block. So you say if data, or if there is an error, and then you're supposed to do whatever is it that you want when an error is encountered. So in most cases, I mean, not in most cases, in some code snippets that I've seen people write, they generally just check for data and they don't even write the else if block. I mean, in a way their code works, but again, we are talking about best practices. So as a best practice, make sure you include the else if block on all your wire functions. Now, in case you have wired your method to a property, you'll have to check for the error in your HTML template. So you're going to have to specify a template if true, and then property.error, and then handle that error inside it. So, but you will have to handle it. Now, how do you handle errors after the value is provisioned? So you have your if data, and then you have all of your logic inside this block. So because again, it is considered to be a synchronous execution. So you can just put a try catch within the if statement, and then you can handle all of the exceptions that occur when you are processing the value. Pretty straightforward actually. Nothing much to get confused on this. But let's see what happens with the imperative calls. So whenever you're trying to call Apex imperatively, it follows the syntax of a promise. So even promises tend to work this way, where there is a method that you call, and this is where your Apex is going to get invoked, or a bunch of logic is going to get invoked. And just like your future method callout, you can just call this method. And once the method decides it has enough data to come back or an error to come back, it calls the then block or the catch block, depending on if there is an error or if there is no error. So this, the call of the then and catch blocks happens asynchronously, which means putting the entire get contact list and all of this within a try catch block is not going to help you, because once the result is given by the method, both of these happen asynchronously. And we have already established that try catch can only handle within a synchronous transaction. Now, to handle the errors, you just need to specify the catch block. So you say get contact list dot then. You also need to have a dot catch, which is going to handle all of the errors. But the most important thing to note here is this is going to handle the errors from the entire chain, which means, so let's say the get contact list method throws an exception. It's going to be handled by catch. And in case this is successful and you have written some logic inside the then block and some error happens within the then block, even that is caught by the catch block. So what this means is within the then block, you need not really put a try catch statement because it is not needed. Any errors from the then block also going to catch. So just with a simple catch statement, you're able to handle the errors from your Apex methods and your business logic that you write. Now, what happens if you're chaining different methods together? I mean, here, let's see what we are doing. We are trying to get the contacts. And once I've received the contacts, I'm again invoking a different imperative method to get all the cases related to that contacts. Hypothetical scenario. I mean, you could do all of it in one transaction. But because I wanted to show you this example, it is this way. Now, once you got all your cases list, then I'm going to get all the files from all the cases. So assume this hypothetical scenario where 1, 2, 3, I'm making 3 method callouts. There are multiple points of failure. Line number 1 can fail, 3 can fail, 6 can fail. And any logic that I put within this then block and this then block can also fail. But notice there is only one catch block and it can catch all the errors in the entire chain. So anything from top to bottom, a single catch block is going to handle all of those errors for you. So it's extremely important that all your promises must have a catch statement. So that is the best practice key takeaway for you today. Make sure all of your promises end with a catch block. Okay, so moving on, what else is left? Okay, so errors during your component lifecycle. So we spoke about all of these wire methods, imperative methods, and your synchronous, asynchronous logic, which gets executed maybe when you click a button and all of it. Now, what about your component lifecycle? There are these 3 hooks that are there: your constructor, connected callback, and rendered callback. And now how do you handle that? It's actually pretty simple because you can put your logic inside the lifecycle hooks within a try catch block, and that should be enough. Now the second one, what can happen is you should not be computing the properties inline. So I'll show you an example. So here in this piece of code, both of these are properties of your class. Line number 2 is name. Line number 3 is full name, but what I'm saying is name.to uppercase. So again, the same uppercase example. Now this is going to result in an exception, and people who have tried it, you know you cannot put a try catch block here because these are our properties. Now this is not really recommended because of the reason that you can't handle errors. What you have to do instead is use a getter for it. So no computing property values inline. Use a getter function and then compute the values for the properties. Now the best practices, we spoke about try catch quite a lot, and one common thing that all of us do is wrap all of the code inside one single try catch block, which works. I mean, it's not going to give an error in your production instances and all of it, but it's a really bad practice. You're not supposed to wrap all of your code inside a try catch block. You actually need to split your code into different modules, decide which one is doing what, and in case an error occurs in one particular piece of code, how do you handle that error? So the way you define your try catch blocks has to be dependent on how the errors from those blocks have to be handled. If errors from different blocks have to be handled in different ways, make sure you put multiple try catch blocks. And now when it comes to the catch block, again, one very bad thing that all of us do is just write a console.log statement and do nothing with it. So that's really bad. We are going to talk about that in a little bit, why it is bad and stuff. But within a catch block, you should only handle the errors that you expect to see in it. So for example, there is a piece of code and then you have put a try block around it. And inside the catch block, you expect the maximum error that you can get is, let's say, missing parameters. So that is what your catch block has to do. If it encounters something else, it has to throw them back. So throw them back as in it has to be propagated to all the other hierarchy in the parent, which we are going to see. But a best practice is that handle only what you expect to see and propagate the rest further for all the other components, other piece of logic to handle it. And even within Apex, that is sort of the best practice that we recommend. I mean, when you put a try catch block, the catch block should not just say exception E. You actually need to specify multiple types of exceptions, let's say query exception, DML exception, and finally write exception, so that if one thing gets missed in all of these three, the final exception catch block is going to catch all of the errors. So it is a best practice out there. We rarely use it, but it is recommended that we use it. Now with LWC best practices, that is what we are trying to tell you. And we mentioned that rest of the errors should be propagated further. Now let's discuss a little bit about how you can propagate these errors. Okay, so whenever you're trying to propagate these errors, there are two kinds of errors that you have. One is synchronous errors that occur in our synchronous logic, and asynchronous errors, of course, occurring in asynchronous logic. Now, whenever your child component throws a synchronous error, and you're not handling that error, assume there is no try catch, assume there is nothing. So this is an unhandled error. It tries to find a handler. Basically, whenever there's an error, it actually looks if somebody is going to handle it. If not, it's going to get thrown to the parent component. And if the parent component also doesn't have a handler that can handle that error, it's going to get thrown to the Lightning runtime. And the Lightning runtime is actually going to handle that error and show a nice little pop-up saying that something went wrong. So that's the way it works. But asynchronous errors work in a slightly different way. So very similarly, from your child component, it gets thrown to the parent component. And if the parent component is not able to handle it, it actually gets directly thrown to the browser. Okay, and in some scenarios, the Lightning runtime is going to show those errors as well, but in very rare scenarios. And let's actually take a look at a demo to see how that works. So here in VS Code, I'm going to show you the code that I'm going to run so that you will get to know how these errors work. So this is a very simple hello binding recipe. I have repurposed it for this purpose. And here I've made a small mistake. So instead of saying event.target.value, I've said event.targets.value. So this is going to be my synchronous error that's going to get thrown. And then I have another component called lifecycle async, in which I'm doing the same thing, but I've wrapped it inside a promise so that this thing gets executed asynchronously. So let's see how it works. So let's go to the lifecycle tab, and we are going to look at our components here. So here, the synchronous errors component is going to throw the error synchronously, which means let me make an error here. So the moment I executed that function, I didn't handle that error, and it was a synchronous error. So it got thrown to the parent, and the parent didn't handle it. So it got thrown to the Lightning runtime. Actually, there was no parent for this. So directly the Lightning runtime handled this error. And because the Lightning runtime handled this error, there is this pop-up that has come out saying that sorry to interrupt. Now, what about asynchronous errors? So here I'm going to do the same thing, but what you'll notice is there is no pop-up that is appearing on the screen, because like I mentioned, asynchronous errors get thrown to the browser, which is why this error is going to start appearing in the browser console. So if you remember, in the previous synchronous example, when this pop-up has come, there is nothing happening in the browser as such. But only when you do asynchronous errors, the browser console is going to start showing this error. Now, what about if you embed your Lightning Web Component inside a flow? Now, that's a different runtime. But since you're embedding a flow inside your same app builder, I mean, your Lightning app, it's also still going to result in an error in the console. But see what happens if I'm running it in a flow. So this is the same flow that I showed you on the home page, but I'm running it in a standalone way. So let me open the console here, and notice if I make the same error, it shows me in the browser just like asynchronous errors would, but the flow runtime has also caught this error. So really, when I say Lightning runtime, it is dependent on whether it is a flow runtime or the app runtime. So depending on that, the errors are going to get caught. Now, why is that important? It is important to understand how errors are caught in order to understand how to handle them. Now, propagating errors. So we understood the life cycle. Now, how do errors get propagated? These unhandled errors are propagated by default. So if you don't handle anything, don't do all of your error handling mechanisms, they are propagated by default through the component hierarchy. But custom errors. So let's say you decide you want to handle an error and you want to throw a custom error of your own. So those can be propagated using two ways. One is using the throw keyword and the other is using custom events. So let's take a look at how those work. So in this example, I'm actually going to show you how I'm going to divide two numbers. And for that, I have created quite a complex setup in order to show how all of this works together. So first thing, in order to divide two numbers, I created a function, divide with throw a and b. And here what I'm doing is I'm throwing an error if b is equal to 0. So instead of dividing it by 0 and returning an infinity value, I actually decide that no, if b is 0, I actually want to throw an error to the parent component. And then I'm exporting this. So pretty simple. I'm creating kind of like a service component. Now divide is my main component inside which I have imported this library that I've just created. And then here what I'm trying to do is I'm trying to call that function by passing two numbers that I accept from the UI. And because I know that divide with throw is going to throw an exception, I've wrapped it in a try catch block. And inside the catch block, I'm handling the exception by saying that I want to show a toast message. So let's see how it works. So for that, again, let's go to error propagation. And this is my component. So this is the divide component, has two numbers, let's say 1 and 0. And the moment I click this button, it's going to invoke my library, which is going to throw the error using the throw keyword. And then I'm going to handle it in the parent component. So I click on divide and immediately you should see this toast message. So what has happened here? You can consider this library to be like a child component where I'm throwing the error. And then the divide, which is the parent component, is going to handle the error because it's been propagated to it. Now, let's take a different example. So I told you can do it in two ways. One is using the throw keyword and the other is using custom events. So here, in the case of custom events, I decide I'm not going to use the library because it is throwing the error. So I write my own custom logic and say if number 2 is 0, then I throw a new custom event. These events that you keep throwing normally. Now, all of us know we can embed this component inside a parent component. So in this case, it is the calculator component that I've created, where I've embedded the divide component. And we know how to handle errors or handle events from the child component. We say on error or on event name and specify an event handler for it. And in calculator.js, you can see the event handler is going to show an alert saying that from calculator component. So that is this. So I have the calculator component inside which the divide numbers, the same component is added as a child. I give the same once and then I fire a custom event. And the event is captured by the calculator component and then shows the error. So there is a purpose of why we threw these errors to the parent component. I'm going to come to that. And the purpose is propagate errors from lower level components and handle errors in higher level components. So this is kind of considered a best practice where your lower level components like your service components or components that are embedded like deep inside a parent component, they'll have to throw errors and then these higher level components have to handle them. The primary reason for that is the lower level components might not always know what is the best course of action to take. So consider this example where divide library is present. So because this is a service component, and if I decide I have to throw an error, and this service component can be used in multiple different ways. So how will the component decide what is the best way to show it? Maybe in some cases the best way is to just show a console log, or maybe you want to show a toast message, or maybe you want to show an entire new component that is an error component whenever an error occurs. So because your lower level components might not always know how the error can be handled and shown to the users, it is best to throw errors from them. And your higher level components, like in this case the calculator component, is going to handle all of these errors and take the appropriate course of action. So when building a calculator, I've built the divide component. Similarly, I can build the addition, multiplication, and all of them. All of them can throw errors. And in just one single component, that is a parent component, I handle all of the errors and show them in a consistent way. So that is the different advantage, consistency. If each component handles the error in its own way, consistency is lost. I mean, if you're looking at a calculator, if you add, the error is shown as an alert. But if you subtract, the error is shown as a toast pop-up and the user will get confused. So that's not something that we want. So as a best practice, do this, take a screenshot. And moving on, there is one thing that I want to spend a little time on this hierarchy and how you can handle errors in the parent. And that is the error callback lifecycle hook. So other than the hooks that you already have, like your connected callback, disconnected callback, you also have this thing called as error callback. And the primary purpose of this is to catch all the errors, all the unhandled errors from the child components. And yeah, it's going to include errors from the descendants lifecycle hooks. So basically any error, synchronous or asynchronous, whether it occurs in a child component, the error callback lifecycle hook on the parent can catch all of these different errors. Now, one thing of importance to note is errors from programmatically assigned event handlers won't be called. So if you have an on-click handler and you're adding that using button, on-click, and then giving a handler, error callback will work for that. But if you're assigning the handler through JavaScript by saying this.template.button.add event handler, in that case, the error callback hook is not going to get executed for any errors happening within programmatically assigned handlers. Now, one thing is it only catches errors from its descendant components. Any errors happening within the component itself will not be caught in the error callback. And finally, the framework is going to unmount the child component. Let's actually take a look at that. So here I have the same calculator component like before. I have embedded the C divide, but then I have put the error callback as a lifecycle hook. As you can see, the error callback lifecycle hook is going to take in the error and stack parameters. And I'm going to show an error here saying this.alert. It's getting called from here. And let's take a look at it in action. So here it is 1, 0. And now what I'm doing here, it is the same divide component that we have used here, which means I'm handling it from the library. So the library is going to throw the exception, but the divide component itself is not going to handle that exception. It's going to let it propagate to the parent. So the moment I click this, you'll see that the error is getting called from the error callback hook. And the component is unmounted, which means the component in which the error is occurred is actually removed from the DOM. So this is one thing with the error callback hook. Remember that if an error occurs within the component and the error callback catches it, it removes the entire component from the DOM. So that is about the error callback hook. How you can use it is, I'm calling it the safeguard pattern. There might be an actual different name out there I don't know about, but the safeguard pattern, what it says is to safeguard all of your components, you actually create what we call as the boundary component. And what the boundary component does is, if you see, the JS file has the error callback function, and any error is put into the this.error property. And within the HTML file, we say if true this.error, then we show the error. If not, we put our component here. So whatever is your final component that is there, you're going to put it here, and basically wrapping your final component inside a boundary component. So any errors that you leave unhandled or any unexpected errors that you get are still caught by this boundary component. And as you know, your component will be deleted from the DOM. But since the error is logged, it's going to show the error panel, which means the user is not going to see your component anymore. They are only going to see, oh, an error occurred, and whatever is the corrective course of action that you give, like refresh your browser or all of those things. Now, all we have done till now is we have seen how to catch the errors, we have seen how to propagate the errors, but the most important thing is how do you display and log these errors. So before understanding how to display these errors, you must understand what is the structure of that error. So errors can occur in various different places in JavaScript, and not all of them have the same structure. So let us again see an example for that. So here we have the error types Lightning Web Component that I created, where I've done all the different operations that I can. I have a wire method which is going to throw an error. I have a synchronous logic. I have my Apex unhandled error. So if you remember, we were talking about how Apex throws different kinds of errors with different level of information. So we have Aura handled errors, custom handled errors, and then we are using Lightning Data Service also to create records, and we are going to look at the errors that are going to come from that. So for that, let's go to the error types, and let me clear the console. And I'll click on show errors, at which point all of my code is going to get executed. All the errors are going to get thrown. And yes, a bunch of different errors. So you can see a JavaScript error. Let me make this a little bit bigger for you. So the JavaScript error, as you can see, has three properties: name, message, and stack. But if you come to the Apex unhandled errors, the exception type is thrown. So you can see the structure basically here as body, exception type, message, and stack trace. When it comes to Aura handled errors, the body itself is only going to contain message and nothing else. When it comes to LDS, Lightning Data Service create record errors, again you're going to have a body inside which you're going to have the error as the property name, no message or anything. So this is again a different structure. So custom exception again is going to have a body, then is going to have exception type, message. Basically the purpose of this is to really tell you there are different structures, and sometimes if you're getting the records, the message that is returned might not always be a single object. It can be an array as well. So all of these bunch of different types of errors are there, and you need to find a way to parse all of these different kinds of errors and come up with a standard structure, for which of course you can create a library of your own. But what our tip is, you can use the reduce errors function from Lightning Web Component recipes. So within recipes, we have this function that we have put, which is open source. You can just use that function. I mean, import it into your own web component, use that function, and then work with it. So let's see how to do that. So this is the same exact component, which I call error types reduced, where I'm actually importing the reduce errors function from LDS utils. So this is the component in which this function is present in. So import this function, and then wherever you are trying to log your errors, just put it inside the reduce errors function. So here, instead of just logging console.error, I'm saying reduce errors of error, and it is the same thing that I have done in all the places where I've logged the error. And to see it in action, again clear the log. So error types reduced, click on show errors. And what you'll see this time is the same exact errors, but all the format is standardized. So the function has picked up the error message from all of these different types, and it is showing it to you as a string array. because you can contain one error message or multiple error messages. So it's going to be an array that is returned to you. For any kind of error in JavaScript, just use the reduce errors function and it's going to get standardized. So that is really the purpose behind the reduce errors function. Now, once you have captured the errors, you have standardized the format of the error, the next step is to display it. And the best practice is don't just display the error, also tell what has to be done to overcome that error. So in case there is an error, it should not just say, oops, an error occurred. It has to say, oops, an error occurred. Please refresh your browser to try again, or maybe try submitting it with valid data, or contact a system administrator. There has to be a corrective course of action. And the most recommended way to show an error is near the point of failure. And if the error has occurred in multiple places, you can show a toast message on the top that says, okay, there are so many places in which an error occurred. Navigate to each of those places and see. And these base components, in case you use them, they provide a nice little way in which you can show an error message. And the advantage that you get with base lightning components is that it is all accessible, which means it conforms to all the accessibility standards. So if there is an error according to accessibility standards, you are not just supposed to highlight it in red, because if you just use a color code, somebody who's not able to distinguish between colors will not be able to identify that there is an error. So there has to be a supporting message and all of that. So the way you can do it with base components is pretty simple actually. You just query select the component, and once you get to that component, you can set a custom validity message using .set custom validity, whatever is the message that you want to give out. And in the end, just say element.report validity. So with just these three steps, I mean, it's validation. So in the end, there are going to be if else conditions. So in these 3 lines of code, you're actually able to set a custom validity message without you having to worry about styling and all of it. So the way it works, again, pretty simple. The base component error, this is the first name, and I just click me. You can see that my custom error message is shown here and the validity has been reported. So this is one of the ways in which you can report errors. And if you have a huge form, you can put this on all the different elements that are there. And finally, you can also show a toast message saying, okay, we have encountered so and so errors, please rectify them. So that is one way, display error. And finally, I was talking about consistency previously. You need to display errors consistently across the entire application. The tip that we are going to give out, I'm going to give out, is use the error panel component from LWC recipes. So you can just use that panel and just pass the error message that you get. So if you look at the syntax, see error panel, and any error message that you have, you can just pass it as an attribute to this. It uses the reduce errors function in the backend, and it has a nice little UI in which it shows the error. Actually, you've already seen that UI. So in the Apex errors, whenever I've invoked it, you see this area. It shows a picture, it shows error retrieving data. So this is the error panel component, and it also has the show details. You click it and it actually shows you the exact error message. So this is the component we've built. I mean, you can customize it to your own, because in the end, recipes is open source. You can do whatever is it that you want with it. Finally, logging errors. So I mentioned people generally tend to log errors to the console. I would recommend do it only during the development phase. So during the development phase, log your errors using console.error instead of console.log. Primarily because console.error is going to preserve your stack trace, not just from where you threw the error, but from the original cause of the error. It's going to retain it. And most importantly, don't forget to remove your console logs or console errors before moving it to production, or for that matter, UAT. Because this might happen. I mean, the screenshot that you see on the right is from one of the courier services that I was interacting with recently. I put in my mobile number and then I submitted it for an OTP. The OTP was supposed to come to my email in, let's say, 10 seconds, but it didn't happen. It took 10 minutes. So I decided to see if I could get the OTP from the console, and it turns out they have logged the entire response object over here, including the OTP number. So this is a very bad practice because OTP is supposed to be a secret, which really means in case I didn't have my phone with me, I could give some random number, telephone number, get the OTP from the console log and put it there, which really defeats the purpose of two-factor authentication. So please don't make this mistake. Remove all your logging statements from your code before moving the code to production. That is one reason why, because of security. And the second reason is in production, console logs don't really add any value to you. So in case an error occurs, you cannot expect the users to open your developer tools, take a screenshot of the console log that comes there. You'll have to actually log all the errors to the server. So it is actually critical to log all the errors to the server, which is what is the recommendation for production. It helps you track the issues, it helps to debug the issues, it helps to identify patterns on when the error is occurring. A lot of good stuff will happen once you log errors to the server once you go to production. Now, in case you're wondering how to do it, I found this nice little library built by the Salesforce community, which actually has all the functions that you need to log the errors. Just check it out. I found it to be helpful to standardize reporting of errors across all of the application. So finally, before leaving, a few best practices. It is actually better if you don't handle errors, if you decide to handle them poorly. So let me again give you an example. So here I have again a statement which I have wrapped inside a try-catch block. If this throws an error, it's going to display a nice little toast message, which is good. And then I say there is a better way of handling the error, which is not to handle the error at all. And there is the worst way of in which you can handle an error is by enclosing it within try-catch and logging the error to the console. To see it in action, let's go back to the error types tab and look at improper handling. So if I click on the button best, it's actually going to show me the toast message. So I know something wrong has happened. And in case I click on, let's say, better, you'll see I haven't handled the error. So it was automatically handled by the Lightning runtime, and then a pop-up has appeared. So the user knows that something bad has happened. And then the worst way is I click the button, the errors are getting logged to the console, but as an end user, I don't have any indication on the screen. So that is why I said, if you decide to handle errors poorly, a better way is to not handle them at all, because little at least the Lightning runtime is handling it for you. And all your error handling, make sure you check all the boundary points of your application. So let's say any calls to the server, third-party libraries, external services. So these are called the boundary points, and you're expected to handle errors at all of these different points. And of course, I've mentioned this during the server time, server-side errors and the client-side errors. Decide on a common structure to either catch the errors, report the errors, display the errors, and use this common structure across all of your application. So that is handling errors. And where to go next? So check out my blog post. As a matter of fact, everything that I've blabbered today, I've put into a blog post, which is already live since August 17th. And the link to this blog post, I'm going to put it in the chat if you're viewing it live. It's also going to be in the description if you're viewing the recording. So check out this blog post if you don't want to listen to this video, and you'll have all the same best practices that are dumped in there. So with that, I would like to say thank you for taking the time out to listen to this session, and have a nice day and see you soon.